Here is podcast 2. There are 2 sheets on your sheet of paper. We're just going to cover the front today on this short podcast and then back on another day. So we want to look at life molecules. Water is a really, really important life molecule because most of your body is made up of water. But if we look at this part right here, right? If we look at these images, there's 2 properties of water that are really, really important to life. The first one, water absorbs a lot of heat energy, and what you need to write down here is what that deals with. So what that really means is that it takes a lot of energy to heat water up, and then it takes a lot of time for water to cool down. And think about how much time it takes for a pot of water to boil. It takes some time, or you've got to really, really crank up the heat for it to boil quickly. And then once it's heated, it takes a long time to simmer down. So if we look at this picture right here, what this allows for us as individuals is that we can live in very warm temperatures and we can live in very hot temperatures, right? So it takes a lot of heat to heat our bodies up to the point where it's dangerous, and when you have heat stroke, that's what occurs. And then we can live in colder temperatures. It takes a lot of time and a lot of cold temperature for our body to lose enough heat to where we might have hypothermia or freeze to death. So it definitely allows us to live within a wide range of temperatures. This next one, water is less dense as it's a solid form. So what we see is ice floats. And why that's important for animals is that because ice floats, water freezes from the top down, not from the bottom up. If it froze from the bottom up, then every winter when the ice would freeze, organisms that live in those aquatic environments would essentially freeze to death. So that's not good. So it's important that ice floats for those that live in aquatic environments. So we're going to move on down to chemical properties of water. Again, we look at H2O here. H2O, we have the H, 2 H's and no hydrogen bonds. That's what these all are symbolizing. The hydrogen of one bonds to the hydrogen of another. You put a whole bunch of those water molecules together and you get what you see in a glass, which is water. So water is both adhesive and cohesive. And what that means is that because of the hydrogen bonding that occurs, water can stick to itself, and then it can stick to other molecules, mainly because it's polar. But because of that nature of water, you can actually get a column of water to move up as gravity is pulling it down. So if you think of plants have to take water all the way from the ground all the way up to its leaves to go through photosynthesis against gravity. So because the water is sticking to those the roots themselves, and water is again sticking it to itself, you can move a column of water up. Same scenario in our bodies when we have blood on our toes that has to go up to our heart or up to our lungs. We got to move against gravity. So it's that adhesive and cohesive nature that keeps it all together. So a big reason why that is because water is polar. Right? Water is polar. We look at polarity, and we want to look at the picture there. We have water is slightly negative at the top, and that's what it means. All right, a slight charge. A slight charge on one end. All right? Because of this, water is able to dissolve many substances, and we actually call that the universal solvent. Right? Water is the universal solvent. I'm going to erase this here, get this out of the way. Universal solvent. And again, that just means that water dissolves stuff because it attaches. Okay. It attaches to these molecules and literally breaks it apart. So because of that charge. And of course on life, if we look all the way up here, most of our life processes happen within water. And the key terms here are osmosis and diffusion. And as water gets, as nutrients come into the body, water is going to diffuse out. All right, and that's really important. And so water is able to dissolve many substances and therefore can carry nutrients into the cell and water out of the cell. So that nature allows things to come in and out. And something that water plays a role with is pH scale. So we have, again, 7 is neutral, that's water. And anything below is an acid, anything above is basic or alkaline. And most of our body cells function within a fine range of pH, and this buffer system helps regulate. Water is a buffer system that helps regulate the pH. And what we're really looking at maintaining is sort of an optimal pH. We really want to get as close to 7 as possible, and that's because the enzymes function within that narrow range. And if the enzymes are in a situation where the pH is too high or too low, they denature. And looking at our picture here, when they denature, the shape has changed, and they can no longer do their job and carry out the process. So it's really important that water kind of acts as that buffer system. So there are your notes for the first sheet. We will do sheet 2 and then the quizzes next.